Hi students, welcome to my YouTube channels. Today again I came for new psychrometric problems. These problems I taken all those unknowns. So almost two problems I combined here. So once you will understand these problems, psychrometric, any problems you can solve. So in simple steps again I am going to explain this. So what is the given the problem? In a laboratory test, a ceiling psychrometry recorded DBT and WBT 30 degree and 25 degrees temperature respectively. Then they are asking calculate partial pressure of water vapor, humidity ratio, symbol will be W, degree of saturation, relative humidity RH, relative humidity, the symbol will be phi, dew point temperature, enthalpy, density of dry air, density of water vapor, all those things I will calculate in these problems. Okay. So, what is ceiling psychrometry? Ceiling psychrometry nothing but is a device from where we will measure the dry bulb temperature and wet bulb temperatures. Already we discussed in the theory, dry bulb temperatures how we will measure? If dry bulb temperature, if exposed to the atmosphere, that moisture will not get affected and will get the temperature. If WBT once will calculate, so in the thermometer bulb, you cover the wet cloth and exposed to the atmosphere, you will get the WBT. So how the DBT and WBT we are measuring? By the ceiling psychrometry. So ceiling psychrometry is a device, there we measure the dry bulb temperature, wet bulb temperatures. Okay, these objective questions we can utilize. So how to solve these questions? So first they are asking partial pressure of water vapor. So formula I wrote partial pressure of water vapor. PV is equal to PW minus PB, PW, TD minus TW. Partial pressure of water vapor, this PV value nothing but saturated pressure corresponding to the WBT, wet bulb temperature. Dry bulb temperature, wet bulb temperature, both should be in degrees Celsius, will take here. Here also TW, wet bulb temperature, 1544 minus 1.44, this is the value. So, how will get the unknown? Barometric pressure is not there, problem also not given. So, previous problems, what I told, if barometric pressure is not given, directly will take from the table 1.01325 bar. That is nothing but 760 mm of Hg. So some problems they will give 740 mm of Hg, 730 mm of Hg. So that already we told the conversion factor. Again I am writing here 1 mm of Hg is nothing but 0.001333 bar. If you multiply this value to any value given less than 760 mm of Hg, we can calculate. So one PV is equal to this bar, but PV value, what is standard value? 760 mm of Hg. 760 mm of Hg PV value. In bar, 1.0325 bar. So in this question is not given, directly we will take this value. Okay, this is the conversion factor. 1 mm of Hg is equal to 0.001333. If anything they given here, I like 740, 750, 755, 720, whatever value less than 760, multiply this value 0.00133, so we'll get the PV value directly. Next, how we'll get the PS value? PS value will get the dry bulb temperature. Dry bulb temperature. So what is dry bulb temperature is given here? 30 degrees Celsius. So corresponding 30 degrees Celsius, what is the vapor pressure? PS 30 degree. Already table I wrote in here. So 0.042431 bar. Now what is PW? Corresponding to the wet bulb temperature we will take. Wet bulb temperature. This is given 25 degrees Celsius. So from 25 degrees Celsius, what is the value? 0.031671 bar. Now look here. This table, refrigeration of psychrometric tables available. This also allowed in the exam. Any type of exam you will write now, this table will be allowed. Or this some exams table not allowed now, this value they will give in the question itself. So this value, the table temperature minus 40 to 50 degrees Celsius corresponding to the vapor pressures will give in the table. So I taken the few value, what value needs for that my particular problem. So that value I wrote here and I am writing now here. Okay. So this PS value, PW value, PV value you know. Now substitute this PV problem. If you substitute here, PW how much? 0.031671 minus PV value 1.01325 minus PW value 0.031671, then dry bulb temperature 30 degree minus 25 degree. So as I told, these two value will be degree Celsius. Then 1544 minus 1.44 25 degree. Why 25? Because TW is the wet bulb temperature. If we'll solve this PV value, we'll get some value. So we have already calculations. PV value coming 0.0. PV value is coming 0.0. Yes. Already we calculated 0.028, 0.021 bar. This partial pressure of water vapor we know. So what you are saying, if you know the formula, these two data only, dry bulb temperature, they given 30 degrees Celsius, wet bulb temperature 25 degrees Celsius. Based on this we'll get PS, based on this we'll get PW, and we'll substitute there. Barometric pressure not given, this is the standard value from the chart, we got the partial pressure of water vapor. First one is over. Next, what is relative humidity ratio. So humidity ratio nothing but W symbols I given, humidity ratio. So W formula will be there 0.622 PV minus PB minus PV. PB is barometric pressure, PV partial vapor pressure. This is the standard formula 0.622 PV by PB minus PV. So PV value 0.02821 divide by, okay, multiply pannadana. So wait here. That implies 0.622 into PV value 0.02821 divide by PB 1.01325 minus 0.02802. This is the value. So once we'll calculate W, you will get some value. So W value you will get, already we have calculations 0.0176, 0.0169. Unit will be kg per kg of dry air. So specific humidity or humidity ratio or humidity, this W is nothing but humidity ratio, humidity or specific humidity, this value we got. Third one is degree of saturation. So degree of saturation, again direct formula will be there, PV by PS. This formula will be there, PV by PS, degree of saturation. Just we'll check this formula, PV by PS, correct? Then PB minus PV, then PB minus, this is PV saturation and the PV partial pressure of water vapor. So this value I wrote, formula I wrote. What is this PV by PS? Relative humidity. Directly you can calculate here relative humidity. This symbol will be phi. PV minus PS. PV, what is value? We'll write here 0.028021 by PS value 0.042431. The stop value again will write clear, it will look clear. What is PV value? Just now we calculated 0.028021. If we'll calculate this relative humidity, already we calculated somewhere. Relative humidity you will get 66.038. 66.038 percentage, because it will get decimal only 0.66. So relative velocity you will get actually decimal. Then you can write percentage later on, 66.038 percentage, because relative humidity we are measuring by the percentage. Now this same relative humidity you substitute here. This value PV by PS, relative humidity. How much? 0.66038. Then PB value 1.01325 minus PS value 0.04231. So always you will see this calculations is little bigger here. So this divide by PV value 1.01325 minus PV value 0.028021. So this is the value. So degree of saturation value directly I already calculated. So I will write this value. Degree of saturation value is coming 0.65, 0.65, some decimal value may come. So degree of saturation is 0.065, some value will come. If you will calculate, you will check this, okay. So degree of saturation over, humidity over, degree of saturation over, relative humidity over. Now dew point temperature, enthalpy and density. So generally all those unknowns they will not ask in the same problem. But avoid this, I am solving everything in the same problem. So whatever they will ask, how many unknown data they will ask, you can calculate. So here till now partial pressure of water vapor we calculated, specific humidity we calculated, relative humidity we calculated, degree of saturation we calculated. Now our work is dew point temperature. So we'll see from here dew point temperature. I will rub it here and we'll see the dew point temperature. So how to calculate dew point temperature? See here. Already previous video I told dew point temperature how we'll calculate. So partial pressure of water vapor value you will write 0.02801, 0.02821. This is called partial pressure of water vapor value I wrote. Then what is the method? So dew point temperature, once you are calculating this value, will get from the corresponding vapor pressure temperature. So now this value you will look here 0.280, so that means this value belongs to between 22 and 23. This value belongs to 22 and 23. See here 280, 86, here 21 is there. That means this value bigger. And other just previous value what is 22. So 22 value 22 degrees Celsius value how much? 0.026431. And what is 23 value? 23 degrees Celsius value 0.0288086. Now you look here 0.028086. So how to calculate the dew point temperature? See this method. First partial pressure of water vapor you write middle. You will see this partial pressure of water vapor in which temperatures belongs or which temperature between this belongs. So now you have to see this from table. So this value belongs to between 22 and 23. Between 22 to 23. So 22 and 23 value I wrote here. That means this value could just before value, this value could just after value I wrote, and we'll get the fractions value. Suppose this point you take A, B, C point. This is A point, this is B point, this is C point. So what is the X formula here? What is the X formula? That interpolation method, we get the fractions value B minus A by C minus A. So what is B value? 0.028021 minus what is A value? 0.026431. It's called 23 degrees Celsius here. 231. Now C minus A. So 0.028086 minus A value 0.026431. That value and all carefully you see. Now X value you will get. That implies X value will be some fractions value will come. So somewhere we calculated, we will see this value is coming 0.961. 0.961. This value I know here 0.961. So what is the dew point temperature? Now dew point temperature is nothing but 22 into 961 degrees Celsius. This is the dew point temperature. This way we can calculate the dew point temperature. So partial dew point temperature is coming from the partial pressure of water vapor. That corresponding temperature is known as dew point temperature. Now density of water vapor and density of dry air. This last part we have to calculate. So now this part I will remove now, and this two how to calculate we will see here. So density of the dry air. Last one is density of the dry air. Density of dry air. Formula is 1 by specific volume. Then density of water vapor. This formula will be this density of dry air, density of water vapor, nothing but specific humidity. This W is specific humidity or humidity ratio divided by specific volume. This is known as specific volume. So if you know the specific volume, we can calculate the density of dry air, density of water vapor. How we'll get the density of how we'll get the specific volume? See here, we have formula. PV is equal to MRT. Gas equations, what is there? PV is equal to MRT. So if we'll take here partial pressure of dry air, volume, mass, AT. If we'll consider mass is equal to 1 kg, then this volume becomes a specific volume. If mass will take 1 kg, this volume becomes a specific volume. So PA, VA by MA, if you write here, per unit mass equal to RATA. So this VA, if we will divide the VA, MA, this will become a specific volume. So I need partial pressure of what the Dalton's law partial pressures, what is it telling? PA is equal to nothing but PB minus PV. PB minus PV. This is called Dalton's law of partial pressure. So right here, PA is equal to PB minus PV into VA. Now this VA becomes a specific volume because we are considering M is 1 kg. So R value what is 287 joule per kg degree Kelvin, and this 30 degree because we will take dry bulb temperature. Dry bulb temperature 30 degree. 30 plus 273, it will come 303. 303. So partial pressure of water vapor PB value will be somewhere 1.3. So bar is there. So 10 power 5 you will take common 1.01325 minus PV value will be 0.028021 is specific volume. Then this if you will calculate how much coming, this if you will calculate this value 86961. 287 into 303. If you will calculate this value, we will get the 287 into 303. 287 into 303. This value is coming correct. Okay. Now VA value. If you will calculate here VA value, you will get this, subtract and into 10 power 5 divide by, so this will come division. This VA value we got 0.88265. 0.88265 meter cube per kg. Meter cube per kg unit. Now if you will substitute here, first one if you will substitute here, this we will write later on. If we will substitute here, what we will get? 1 by 0.88265. This value is coming 1.13295 meter cube per kg. So it will come kg per meter cube. This is density of the dry air. Once you want to find the density of water vapor, so this value I told is specific volume by density, the specific humidity divided by specific volume. Specific volume VA. So this value how much? 0.01769 divided by our specific volume 0.88265. This value you will get 0.00042 meter kg per meter cube, kg per meter cube. So look here, this is m is equal to 1 kg. So density of the dry air, density of the water vapor, how we calculating? Dry air na humidity is 1. Water vapor na W, because W is specific humidity. If you will see the psychrometric chart, this value is nothing but a specific humidity. So once moisture water vapor calculating na, this W divided by specific volume, density divided by specific volume, you will get this. So this is the complete psychrometric problem, complete psychrometric. So whatever unknowns is possible, everything I consider in these questions. Okay students. So you once see this video and subscribe the channel, so you will get the new message, you will get directly in your contact. Okay.